Okay, so picture this. Your API is zipping along at 90 milliseconds in the US, but it's crawling at 500 milliseconds in India. It's the same backend, the same code, same everything. So, what do? And hey, before you say just move all the users to the US, nope, not a valid answer. Nice try though.
All right, so let's get into it. This is a classic system design interview question. And you know what? Most people get it wrong. So today, I'm going to walk you through exactly how to think about this the right way. The first thing that comes to my mind when I see a problem like this is almost never an application code issue. Think about it. If the exact same code runs fine in one place but struggles somewhere else, your number one suspect has got to be the journey itself, the distance, the network hops, the whole data path. It's probably not your API handler.
So that's what latency really is, right? It's that whole round-trip time. And before we even think about solutions, the first thing we absolutely have to do is break that latency down. We got to see where the time is actually being spent.
So how do we do that? Well, we start by diagnosing the problem. And if you're in an interview, this means you start asking the right questions to really break down that journey. Okay, so if I were in that hot seat, here's what I'd start asking. First off, how much of that 500 milliseconds is just waiting for the first byte, the TTFB, versus the actual backend processing time? And where is our app server physically located? Is it just in one region? And this is a big one. Where is the database? Are we doing any reads or writes across regions? And finally, are things like the TLS handshake, DNS, or even our WAF routing traffic differently depending on where the user is? And this is where you get that aha moment. Let's say your backend compute is super fast, maybe only 50 milliseconds. But your users in India are still seeing a 500 millisecond response. Well, there's your answer. The problem isn't the code, it's the path the data has to travel. And that really brings us to the core idea here. You've got to shift your thinking. You're not fixing a slow function, you're fixing a slow journey.
All right, so now that we know what the real problem is, let's talk about how to fix it. I'm going to walk you through 4 key strategies to speed up that journey.
Okay, so here's the game plan. We're going to look at 4 main ways to tackle this. We'll bring the compute closer, bring the data closer, make fewer trips back and forth, and use the edge to our advantage. First up, closer compute. This is pretty straightforward. You just serve users from a region that's physically closer to them. So you deploy your app servers in India, or maybe a nearby APAC region. Then, you'd use something like geo-DNS or a global load balancer to automatically send users to the server that's nearest to them. Number 2, bring the data closer, especially for reads. Seriously, your users should not be waiting for a database that's, 14,000 kilometers away. So you can fix this by adding regional read replicas for your database, using an in-region cache like Redis for all those hotkeys, and maybe even caching some semi-static API responses at the edge. Third, let's talk about making fewer trips. You really want to avoid those chatty APIs. You know the ones. They make 5 or 6 different calls when just one bundled request would have worked. And make sure you're using modern protocols like HTTP/2 or 3, along with features like connection keep alive. And number 4, use a CDN. Put an edge layer right in front of your service. You might think this is just for static files, but even dynamic APIs can get a huge boost from this if some of the responses can be cached. I'm talking about things like configs, feature flags, metadata. This one change alone can shave off hundreds of milliseconds. Okay, now for the most important part. Let's talk about the trap. This is where a lot of engineers stumble in an interview, and it's what really separates a good answer from a truly great one. So, what's the common mistake? Someone will say, oh, that's easy. Just move the app server to India. And yeah, it sounds logical at first, but it's a dangerously incomplete answer. Because the interviewer is just going to nod and then hit you with the follow-up. Okay, you moved a server to India, but where's your database? See, if your app server is now in India, but every single write still has to travel all the way across the ocean to a database in the US, well, congratulations, you didn't fix the problem, you just moved the bottleneck.
This is what you have to call out. You need to say, look, if our app is mostly doing reads, then regional replicas will solve a huge chunk of the problem. But if it's mostly writes, now we're in a whole different league. We're talking about a much harder problem, multi-region write architecture, dealing with replication lag, and figuring out if our product can even handle eventual consistency. Just knowing to bring that up, that's what makes for a great answer.
All right, let's bring it all home. How do you put this all together into that perfect answer for an interview? So here's how I'd frame it. I'd say something like, my first move wouldn't be to change any code. First, I need to measure and find out where that 500 milliseconds is actually coming from. Assuming it's geographic, I'd start by placing the compute and the read paths closer to our users in India. We can do that with geo-routing, regional app servers, read replicas, and edge caching. And then I'd immediately point out that the remote database is now our next bottleneck, because the real fix is about reducing those cross-region hops.
You see, an answer like that, it's powerful. It shows you're not just thinking about one thing. It shows you understand latency decomposition, global architecture, caching, routing, and most importantly, those really tricky consistency trade-offs.
And what this does is it effectively solves for reads, which is awesome. That's a huge step. But it naturally leads to the next, much tougher question. Okay, we've fixed the read path, so what's our strategy for writes? Always thinking about that next bottleneck. Well, that's the mark of a truly senior engineer.